Okay, good afternoon, folks. Section 5.5 is upon us, where we're going to be talking about rational equations and solving them. Okay, solving rational equations, and that's our first objective. It's to solve the equations, and our second objective is to solve formulas that involve rational equations. So it's basically the same thing, only we'll learn some formulas. All right, if I start with practice problem 1, which is here, here's an example of our problem set. So I got x over 2 plus 3 over 5 equals 1 over 5, and I want to, what do I want to do? When I have equations now, I want to solve for x is what I want to do. All right, so when I have equations, however, we want to eliminate the fractions, what is commonly known as eliminating them. Okay, so that means I want to multiply both sides of the equation by the LCD, or each term in the problem by the LCD. All right, so what will happen here is if I've got 2 and 5 and 5 as my denominators, I want to know what's the LCD of 2 and 5. Okay, the LCD of 2 and 5 is 10. So that means I'm going to multiply each of these terms in this problem by 10. Okay, and when I do, let's see what happens. Let me make sure I wrote that problem down right too. I'm having trouble with that this semester. Okay, so here I've got it. It's going to be 2 goes into 10. Now the denominator will always go into LCD evenly. All right, so that's kind of cool about this. 2 goes into 10 5 times, and then 5 times x is 5x. The denominator is gone now. I simplified it by dividing it into 10, the 2 into the 10. Next, I'm going to go, it's plus sign, 5 goes into 10 2 times, and 2 times 3 is 6. And then that's going to equal 5 goes into 10 2 times, and 2 times 1 is 2. And you can do the math your way. This is I'm forward thinking, and 2 goes into the LCD. If you wanted to reverse that and say 10 divided by 2 is 5, and 5 times x is 5x, that's perfectly fine as well. Okay, maybe more soothing to you doing it that way than, it may appear I'm going backwards. But to me, it's a forward way of saying the same thing. All right. Nevertheless, this is my equation now. So all I'm going to do is subtract 6 from both sides, and I end up with 5x equals -4. If you divide both sides by 5, then x is going to equal -4 over 5, which is right here. Okay, so that's kind of like what I'm doing. I'm eliminating the fractions by multiplying by the LCD. Or if you still want to get the denominators to be the same, you can do that. Okay, but then you discard the 10. Now there's a certain rule here I'm going to share with you now. So if I, let's see if I can do that. If I had this problem set up as if I was getting them to be 10, all the denominators, then I would I really can't do that here. Let's try that here. So if I had, here's another one. This is the example one. This is x over 2 minus 3 over 1. And that's going to equal 2 over 3. Okay, so let's see what happens here. If I get all my denominators to be 6's, then I would multiply the 2 by 3, top and bottom. The 1 I'd multiply by 6, top and bottom. And the 3 over here I'd multiply top and bottom by 2. Okay, so now what do we know? We know the denominator is 6. Okay, but I'm not, when all the denominators are the same, I can just concentrate on the numerator. And I'll show you what I mean by that now. So I've got here, the first one is going to be 3x over 6 minus 18 over 6 equals 4 over 6. Okay, and as part of an equation now I can just worry about the numerators. I don't have to, since the denominators are all the same. I don't have to. If I wanted to clear the fraction now, well, geez, I'd multiply everything by 6. And if I did that, this is a mathematical way of speaking to this, I'm multiplying everything by the LCD, which is 6, and then what happens? The 6's just cancel out. They just cancel out for each term, and I'm left with 3x minus 18 equals 4. And then I would go ahead and solve for x. Okay, add 18 to both sides. And it looks like that's going to be 3x equals 22. And divide both sides by 3. Then I'm going to have x equals 22 over 3. Okay, and that's what your answer is in the book. So that's what I'm talking about. If you did it, and I'm speaking to people that like to get the denominator to be the same, once you do, if these numbers are the same in the denominator, you can discount those. Ignore them and just worry about 3 times x minus 18 equals 4. 2 times 2 is 4. And this would be your problem that you're solving for. Okay, just wanted to touch on that with you. Hopefully that was valuable. But let's move on to our practice problem 2. Okay, so with each different problem you have kind of 2 ways of doing it, and some are beneficial more than the other. So in this problem here, I can see what the LCD is. It's 3 times x minus 5. So if I multiply everything by 3 times x minus 5 without actually doing the multiplying, then this would be 3 times x minus 5. So 3 times x minus 5 times the 4. And I'll multiply this side by 3 times x minus 5. Multiplying by the LCD. And that's what the LCD of this problem is. Now when I go to simplify the left side here, the x minus 5's cancel out. And I've got 3 times 4, which is 12. And 12 is going to equal the right side. And what happens with the right side? The 3's cancel out. And I'm left with 4 times x minus 5. And I'm going to distribute that because I got to solve for x. Okay? Oh, do I have to? Oh, I might as well. So you don't have to, but I'm going to go ahead and do it. 4 times x minus 5. This is what I've got so far. All right, so how about 12 equals 4x minus 20. And then I'm going to add 20 to both sides. And what is this here? 32 equals 4x. Divide both sides by 4, and x is going to give me 8. And that's my answer. X equals 8. Okay, and if I come back up here again, and I just want to do this the other way too. So you have to realize you have choices you can make. Here I got 4, same problem, 4 over x minus 5, and that's going to be equal to 4 over 3. And if you kind of know this already and you don't want to listen to it, you can fast forward. I won't know. I don't mind anyway. Okay, I'm happy for you that you know this. Okay, so I got 4 over x minus 5 equals 4 over 3. I want to get the denominators to be the same. Just the alternate way of doing this. So I want to multiply this left side by 3, top and bottom. The right side I want to multiply by x minus 5. X minus 5. And now you can see I got the denominators to be the same in the equation, so I can ignore that and just do my numerator. 3 times 4 is 12. That equals 4x minus 20. And you can see we're right back where we were before. I added 20 to both sides. There's my 32. That equals 4x, and x equals 8. So the lesson here, mini lesson that I'm trying to teach you, is you have choices now to make of what you want to do. Some folks don't like, what's the LCD of x minus 5 and 3? You know, those people struggle with that. So get the denominators to be the same doing it this way, since we've had practice with that before. Okay, and a lot of these may be going this way, where we get the denominators to be the same. It may be beneficial because we're not just dealing with numbers to find out the LCD of 3 numbers. That is not happening in this section. Okay, let's go to practice problem 3. All right, so here we go. And I am going to practice what I preach here. And I apologize for this. I thought we were going to do more with clearing the fraction. I still could do it that way, but I'm liking getting the denominators to be the same. So I want the denominator to be 2 times x minus 5. So that means this x minus 5 I've got to multiply by 2, top and bottom. The 2 I'm going to multiply top and bottom by x minus 5. Okay, I got a little distributive property going on here. And this x minus 5, I'm going to multiply top and bottom by 2 again. All right, so now we can agree that the denominators are the same. So right at this point, I'm going to ignore the denominator and just concentrate on the numerator. So I got 2 times x is 2x plus 5 times x minus 5, and I'm going to distribute it now. And that's going to give me 5x minus 25. Okay, and now it's going to equal 5 times 2, which is 10. And here's my problem. Here's my new problem. Combine like terms here on the left side, I get 7x minus 25 equals 10. Scoot it up here. Add 25 to both sides. And I've got 7x equals 35. Divide both sides by 7. So x equals 5. Check that out. And x minus 5. However, I've got a problem here. Because, and this is what you have to check. Remember, we were checking for what makes 0 in the denominator. And that's what's happening, what's new to us in rational equations in intermediate algebra. I've got x equals 5, but if x equals 5, the original problem here, let's see if I can get rid of that line there. Yeah, x equals 5 here. In the original equation, it was x minus 5. So x cannot equal 5. It's going to make that 0 in the denominator. And so therefore that tells me my answer is not x equals 5. My answer is there is no solution. X equals no solution, or the empty set. It can't equal 5. So that's what's new in solving rational equations. Rational meaning it's going to be in fraction form, but however, we can never have a 0 in the denominator. So that's something you have to be cognizant of. Okay, all right, so that's next is going to be practice problem 4. All right, here's practice problem 4. And we've got this problem, and we're solving for x again. So looking ahead here, I can see my answer, what it's not going to be is that x equals 2 or x equals negative 2. That'll give me a 0 in the denominator. Now this is a quadratic here, x squared minus 4. That's the, what do you call it? The difference of two squares. So I'm going to factor that to be x minus 2 times x plus 2. Which kind of goes with our other two denominators over here, if you notice. And that makes it easier. So this is gone now, so I'll make it easier what to pick out and multiply the top and bottom by. So here I've got an x minus 2. I need an x plus 2, so I'm going to multiply top and bottom by x plus 2. And I'll just write it down here because I know they're going to be the same. Okay, and this denominator, x plus 2, I'm going to multiply top and bottom by x minus 2. And x minus 2. Okay, so my denominators are now the same. And I'm going to concentrate on the numerators. So that means I'm going to have left is x, and that's going to be, I'm going to do this as negative 2 times x plus 2. This minus sign means a negative 2. So that's going to be negative 2x minus 4. Negative 2 times 2 over here is negative 4. And that's going to equal x minus 2. X minus 2 times 1 is x minus 2. Now I'm going to solve for x. All right, so let's get this up here a little clearer. How about we go, what's x minus 2x? Well, that's negative x minus 4 equals x minus 2. All right, and now I'm going to add x to both sides. That way I'll have a positive x. It's going on the right side, but I'm okay with that. So how about negative 4 equals 2x minus 2? How about we add 2 to both sides? Negative 2 is going to equal 2x. Divide both sides by 2. So x is going to equal negative 1. X equals negative 1. And now that will work if I said x could not equal 2 or negative 2, but it equals negative 1, so that's fine. Remember our original problem here, I had x minus 2 and x plus 2. Well, if I plug in x to be negative 1, I'm going to have a negative 3 or a positive 1 for my denominator. So it works. That's going to be fine. Could not have x equals 2 or negative 2. That would make that 0 in the denominator, and therefore it would be no solution. All right, excellent. Let's go to practice problem 5. All right, in practice problem 5, we've got let f of x equal 2 plus 9 over x and g of x equal negative 10 over x squared, and they want us to find f of x equal to g of x. So let's write that up where it's equal. These two are equal to each other. So I've got 2 plus 9 over x, and that's going to be equal to negative 10 over x squared. All right, so as we've been doing, let's get our denominators to be the same. This is really over 1. So it looks like I want to get them all to equal or to be x to the second power. So I'll multiply 1 to be x squared, multiply 1 to x squared, top and bottom. The middle term, I'm going to multiply top and bottom by x. And the third one I'm going to leave alone. So the denominators are the same. And it looks like x cannot equal 0 as my answer. All right, so let's multiply this out. So I've got, I can ignore the denominator, and I'm going to have 2x squared plus 9x, and that would be equal to negative 10. And that's the problem I got to solve for. So it's a quadratic equation. Let's get it equal to 0. How about 2x squared plus 9x plus 10, because I'm adding 10 to both sides. If I want to do it that way. Equals 0 now. So this is it. This is what I've got to factor now. This is the grouping method. So it's 2 times 10 is 20. Two factors of 20 that add up to 9 and multiply to be 20. So that's going to be 5 and 4. The next step is to rewrite the problem to be 2x squared plus 5x plus 4x. That's my 9x. And then plus 10. And of course it's equal to 0. How about we factor this, or group them, grouping method, and factor each of these binomials. So on the left side here, I can take out an x, and what's left is 2x plus 5. Okay, plus sign, copy it down. Right side, I can take out a 2, and what's left is 2x plus 5 equal to 0. Last step, factor out the common binomial factor of 2x plus 5. And what's left is x plus 2. Now here I said x cannot equal 0. So I think we're okay. So here I'm going to set each of these equal to 0, especially the 2x plus 5. 2x plus 5, set it equal to 0, and solve for x. Subtract 5. 2x equals negative 5. Scoot it up, maybe to here, and divide by 2. So x equals negative 5 over 2. And then for this x plus 2, that's easy, x equals negative 2. So those are my two solutions. Let's go back to the original and make sure it won't make it a 0 in the denominator, and it will not. We need x equals 0, and it does not. So that one is done. All right, here's practice problem 6. And let's do some factoring in these denominators, okay? So on the left side, I can take out an a. And what's left is going to be a plus 3. And on the right side, this is a difference of two squares. It's going to be a minus 3 times a plus 3. Okay, so I can ignore these here right now. And this is the factored form, and we want to get the denominators to be the same. So on this side, the left side here, I have to multiply top and bottom by a minus 3. I'll put it over here, a minus 3. That's an a, not a 9. Okay, so then therefore on the right side, looks like I just have to multiply top and bottom by a. Now these denominators are the same. All right, concentrating on the numerators, I'm going to have, well, these are two binomials. I'll multiply. And how about we get a squared, outside is plus 2a, inside is minus 3a, and last is negative 6. Combine like terms, and I've got a squared minus a minus 6, and that's going to be equal to what? Negative 2a. Okay, so here's my quadratic. I've got to get it equal to 0, so let's add 2a first to both sides. I'll put under the like column. And I've got a squared plus a minus 6 equals 0. Let's factor this left side. And I got a here, plus and minus. My number is negative 6. That'll subtract to be 1. So it's got to be 3 here and 2 here, equal to 0. So a equals negative 3, or a equals 2. And let's go back to make sure it doesn't create a 0 in the denominator. Negative 3 and 2. Well, here's my factored form of a squared plus 3a. So if I have negative 3, that will make this 0 in the denominator. All right, so that can't be that side as well. It just takes one side, and the other number is when a equals 2. If a equals 2, we're good. That will not affect our solution. So I only have one answer. This will make it no solution, but this is our only solution of a equaling 2. All right, that was sweet. All right, now we're headed for our second objective about formulas. And here's a formula where we have to have x equals y minus 3 over y plus 3, but we're solving for y. Solve for y. A little bit different here now. All right, but we do the same thing. Let's get these denominators to be the same. And what tells me to do that is I have this in fraction form. This problem is I've got a fraction in it. All right, so that means this is x is over 1, so I'm going to multiply top and bottom by y plus 3. And y plus 3 up top. All right, so the denominators are the same. I can discount it. I have to remember my denominator cannot be y equals, my denominator cannot equal 0, so therefore y cannot equal negative 3. That's one of my provisions here. All right, but let's continue on here. So I've got, let's see, I've got the left side here. What can I do here? I'm going to distribute. Let's see, x times y is xy plus 3x, and that's going to equal y minus 3. Okay? Now, since we're solving for y, and I've got y on each side of the equal sign, I want to bring them together. So I'm going to subtract y first. I'm going to subtract y from both sides. Does that make sense? Subtract y. And I don't have a like term here, but I'm just going to subtract y. So this is going to be xy minus y plus 3x, which equals negative 3. All right, I want to isolate the y's at this point. So here I'm going to subtract 3x. These are unlike terms, that's why I'm kicking it off to the little bit to the side there. I can't combine those, and that's a reminder not to combine them. So now I've got xy minus y that equals -3 minus 3x. All right, now here's the kicker here. On the left side, I want to factor out the y. If I factor out a y, then what's left over? Xy divided by y is x. Negative y divided by y is -1. And that's going to equal this -3 minus 3x. I'm going to take out a -3 on the right side. When I do, I have -3 divided by -3 is 1, and -3x divided by -3 is positive x. Okay, kind of makes sense. And now, to get my y by itself, I'm going to divide both sides by x minus 1. So I can rewrite this problem here to be the x minus 1's cancel. So I'm going to have y equals, and then let's write this up as -3 times x plus 1 over x minus 1. And I solve for y. And that's all I got here. That's it. All right, here's our last one for the day. They're calling these formulas. These are kind of odd formulas, but it says solve the formula 2 over x equals 3 over b plus 1 over a. All right, solve the formula. And oh, I failed to do something important. They're saying solve for x. All right, that means I got to get x by itself. So let's clear the fractions here by getting all the denominators to be the same. So the x, I'm going to multiply by BA, or AB. I'll write AB. They're the same, right? A times B is the same as B times A. Okay, and then the B, I'm going to multiply by AX, AX, and AX. And the A, I'm going to multiply by XB, XB, and XB. Therefore, we have the denominators are the same. BAX or AXB, whatever, however you want to say that. All right, so these are basically gone. The variable for x cannot equal 0. It'll make 0 in the denominator, so that's the only number that'll make it 0 in the denominator. And let's see what we come up with here. So I've got 2AB. AB times 2 is 2AB, which equals 3AX plus XB. 1 times XB is XB. We're ignoring the denominators now since they're the same. This is a lucky break. We got the x's are on the same side already. I'm solving for x, so I want to get those two x's to be 1. So I got to factor out the x. If I factor out the x, then I've got 3a. 3ax divided by x is 3a, plus xb divided by x is b. All right, and that's going to equal 2ab. And now all I have to do here is divide both sides by 3a plus b. And 3a plus b. Okay. Oh, I don't need that. the 3a plus b's cancel out, so I got x on the right side, which is going to equal 2ab over 3a plus b. 2ab plus 3a plus b, and that is our solution. We solve for x. I can't do any kind of factoring and canceling or anything of the sort. So that is the end of this session as far as the lecture goes, and we are not covering Objective C, where we're graphing rational functions, which is very unfortunate, but another class in the future for you, you'll be doing that. All right, that's it for today, and enjoy the rest of the day, and we'll talk to you again real soon.